So, word on the street, you trying to save multiple objects. I got you. So, here's an example. I'm running the game and I want to spawn a fish. Now I want to save this fish and make sure this fish persists between loads. And maybe I get a little intimate with the fish. I want to give it a name, Joe Rogan. Just for fun. Give him 200 health because he's a tough guy. And now if I unload the game and reload, the fish is still there and he's still there with his name and health, and you could spawn even multiple objects, unload and reload the game, and they're all there. I want to explain this save system a little bit before we start. We're going to be saving the files as binary, which is just zeros and ones. This will make our code unreadable so that people cannot hack our game. It will not be stored in JSON or XML. This save system is very similar to Brackeys Save System, except for the fact that it is optimized towards saving multiple objects. One day I'm gonna understand all of this and it's gonna be glorious. Alright? Without further ado, let's get right into it. Alright, so let me show you what I'm starting off with. I have a spawner that allows me to spawn fish that wanders, the spawner script, I have a background, some visual effects, and a fish prefab. Alright, so since I'm going to save a fish, then I'm going to create a FishData class. So I'm going to come in here and create C# script and just call it FishData. This is going to be a constructor class, and go ahead and open it up. Alright, this FishData class is going to be a pretty small class. We're not going to need any of these two namespaces, so go ahead and remove them. We're going to make sure to mark this class as System.Serializable, like this. And this will not be put onto a gameObject, so remove that as well. We will not use any of these functions here. Alright, so I'm going to start off by making a few variables. This is where you get any variables you want to save. For me, I'm just going to use an example health and a public new string name. So I'm going to take these two and actually copy it into my FishData class. And I'm going to make sure I don't initialize them. And take away the new. I'm also going to save the position, so I'm going to make a public vector3, call it position, but there's a catch. You can't save vectors or anything Unity specific like quaternions or colors, but those can be easily broken up into a float array. A vector3 can have a float array with 3 elements, one for the x, y, and z. So that's what we're gonna do. I'm gonna throw this into a float array. I'm also gonna initialize it right here as well. Equal to new float array with 3 elements. Now let's start writing out our constructor. So public FishData, which is going to be the class name, and we're going to pass in the fish, call it fish. Again, you could be saving something else. I'm using smelly fish for an example. So basically what we're doing is we're taking all of the fish's variables and putting it into our variables. Health is equal to fish.health. Name is equal to fish.name. For the position, it's going to be a little bit different. First, we need to cache the fish's position so we don't access it multiple times. So I'm going to create a vector3, call it FishPause. It's going to be equal to fish.transform.position. So now that we cached its position, now we can initialize this position. Position at the index of 0, which is the x, is equal to fishPause.x. I can copy this a couple more times and paste it. Position 1 for the y, 2 for the z, and then come here in y and z. Now you could do it this way, or you can do it another way. Just delete all of this and say position is equal to a new float array. And then you drop the brackets. So now we don't really have to initialize it here anymore. For 1, it's going to be fishPause.x, fishPause.y, comma, fishPause.z. And we put the semicolon on the bracket for some reason. And there you go. The FishData class is done. Now we just need to make our SaveSystem class. I'm going to actually make an empty gameObject, reset its transform, rename it to SaveSystem. Now let's make a class named SaveSystem as well. And then go ahead and drag that class on the SaveSystem gameObject and open it up. Alright, so we're going to be needing to use lists, so we will need this namespace, but we're not going to be using coroutine, so you can get rid of this one. This will be a mono behavior because it's on a game object, and we're not going to need start or update. Alright, so let's just go ahead and start writing the save function. So void save fish, save blank for you, and now we're going to need a namespace to access a binary formatter so that we can format our files into binary. What else are you going to use a binary formatter for? So to do this, I'm going to go up here and say using, and this is a crazy one, System.Runtime.Serialization formatters.binary. Believe me, I know. Right now that we have that, we can make a binary formatter. So binary formatter, call it formatter, is equal to new binary formatter. Go ahead and make a string path. It's going to be equal to, well, it depends on your operating system. You're going to have a different path if you're on mobile or PC, but we can use application.persistentDataPath to do just that. And we can have it on any operating system, and you just simply add onto it your subfile. So instead of just coming down here and saying, /fish and just closing it off, and then whenever we make another function, we write it out again, that's kind of dangerous because 1 times out of 10, you're gonna misspell something and it's not gonna work. So you should jump up here and create a constant string with me and call it whatever you want. I'm going to call it fish sub for subfile. It's going to be equal to this. And if you misspell fish sub down here, it's going to throw error at you, which is beautiful. So do that instead. And now for the path, if you want to make each save exclusive to each scene, you just simply add on to the path the build index of the current scene you're on. So what does this mean? Well, we're going to need a using statement up here. So using UnityEngine.scene management. So now we can use the scene manager. So we'll add on to this path plus scene manager.get active scene. So the scene that we're currently in, parentheses dot build index. So what this is going to look like is fish and then the scene we're on. If we're on scene 1, it's going to put a 0 in front of it because the build index starts at 0. And this is good because in some cases, if you wanted to put your subfile string in front of the build index, well, this is going to give you a problem because if you look at the string here, instead of the number being in the back, it's going to be in the front and behind the slash.
Never go behind the slash.
Alright, so now let's create a for loop. So for double tab, while I is less than all the fish we have. Well, where are the fish? So what we will do is use this beautiful namespace and create a public list of fish and call it fishes is equal to new list of fish. And I'm actually going to make this list static. Why static? Because I want the fish to be able to have a reference to this list without having a reference to the save system. So now I can go into the fish, jump down here, and let's make an onAwake a function. So awake for whatever you're saving, and have your object add itself to the save system's list so that the save system knows what to save. So SaveSystem.fishes.add this. What this does, since it's on awake meaning as soon as the object is instantiated. The cool thing is the save system, when it loads the fish, it'll also re-add itself to the list, so it repetitively saves the object until you take it out of the list manually. So this is also cool because if you buy a fish for the first time, say, then you don't have to worry about adding it to the list or forgetting to add it for the list, which is in most cases will happen. You don't have to worry about it. So on awake, the fish adds itself to the save system. Now for while I is less than fishes.count, let's just make a file stream. And we don't have file streams because we need to be using System.io to access files. Alright, so I'm going to call this stream. It's going to be equal to new file stream. Alright, so file streams take in two things: a path of where the file is going to be, and a file mode access. Are you creating a file? Are you opening a file? Are you appending? All that kind of stuff. So the path is what? the path that we just created plus this iteration. Path plus the index of this iteration. So it'll save each fish individually. Now we'll go file mode dot create because we're saving. And now I'm going to access this constructor here and create a fish data, call it data because this stream needs some data to be put into it. It's going to be equal to new fish data. We're saving the fish of this iteration. So the fishes that are in the list at the index of this iteration. Now that we have the stream and the data, let's go formatter dot serialize. Again, serialize meaning put in, save. We're going to serialize the stream with the data. And don't forget to close your stream. If you don't close your stream, weird things are going to happen and this is not going to work. Next, let's create the load function. So void load fish. Alright, and I'm going to copy these two lines here because it's going to be the same. Make sure you copy your path so that you don't have to rewrite it and possibly mess it up. Let's just create another for loop, double tab, while I is less than fishes dot count. But there's a problem with this. When we're loading, it means that we restarted the game. And when we restart the game, this list will reset. And when it resets, then it doesn't mean anything because there's no fish on it. So we can't rely on this list to tell us how much fish we need to iterate through. Now we need to save the amount of fish that we saved. So when we're loading, we will know how much fish we need to load. So I'm going to go up into our save function, copy this path, paste it here. I'm going to call this count path. And the only thing I'm going to change on this is the subfile string. So I'm going to copy this subfile up here, paste it over here, and I'm going to rename this to fish count subfile. In this video, I actually forgot to change the fish count substring. I didn't change it, but you're supposed to make it look like this. And it only worked for me because when we saved the fish, it puts a number after the fish, which makes it different from my fish count subfile string because this is the fish count. And I'm going to take this and paste it down here. Now we need a file stream for this path. So file stream, call it count stream is equal to new file stream at count path and file mode. Can you guess it? Create because we're saving. Now we can serialize this stream, formatter dot serialize the count stream. And what's the data we want to put into it? The fishes dot count. And don't forget to close the count stream dot close. There you go. We just saved the amount of fish that we saved. Now we need to load the fish that we saved. So I'm going to copy this count path, paste it over here, and now we don't know 100% that this count path is valid, that it exists. So we're going to need to do an if check. If file.exists at count path, then we will recover the data. Else we'll just throw in debug.log error and say something like path not found in plus count path. This way, if the path doesn't exist, it'll throw an error in your log and possibly save your life. Yeah, what he said. Now in here, we're going to recover the fish count. So I'm just going to make an integer down here, call it fish count, and initialize it as 0. And in here, I'm just going to need a file stream, call it count stream. It's going to be equal to new file stream. Again, it takes in the path in the file access mode. So path is at count path and file mode. Now since we're loading, this time we're going to go file mode dot open. And now we're going to say fish count is equal to formatter dot deserialize, so load it or take it out. We're deserializing this count stream. Now it's going to throw us an error. We just need to specify what we're deserializing it as. In this case, we're deserializing it as an integer, so we cast it into an integer. And finally, go count stream dot close. If you forget to close a single stream, none of this will work. Cool, so now that we know how much fish there is, we'll just replace this with fish count. While I is less than fish count, we're going to create a file stream every time, call it stream, it's equal to new file stream at path plus the index of this iteration, and again file mode dot open because we're loading this time. Now I'm going to create some fish data, call it data. It's going to be equal to, so we're going to go formatter dot deserialize. And we're going to deserialize the stream, and it's going to give us an error. We just need to specify what we're deserializing. So it's going to be as fish data. And again, stream.close. That's a game remove right there, guys. One more thing. How do we know path at the index of I exists? So we're going to do an if check. If file.exists at path plus this iteration, drop the brackets, and put everything inside the if statement. Else, copy this message over here so we can throw an error telling us what happened, and replace count path with path plus I. Now that we finally have this beautiful data, we can finally instantiate a fish and give it this data. So create a fish called fish. It's going to be equal to instantiate, and we need to instantiate the fish prefab or the blank prefab. So come up all the way over here and serialize a field. It's going to be of type blank. I'm going to call it fish prefab, and we'll assign that later. But down here we'll instantiate the fish prefab. Now we need to pass in position, so I'm going to create a vector3 position, and it's going to be equal to a new vector3. And this is where we do a little bit of converting. This is where we take our position float array from the fish data. So you go data dot position at the index of 0, which is the x, and I'm going to copy this line 2 more times for the y and z. So comma 1 for the y and data dot position 2 for the z. And that's it for the position. Now I want to stress that you make sure if you're doing it like this, have it in the correct order. It needs to go x, y, then z. So just keep that in mind. Now go in here and pass in the position on instantiation. And now we need a rotation. So I'm just going to go quaternion.identity. Now you can save the rotation if you want to. Just to make this video quicker, I'm not going to do that. You can just save the rotation the same way we save the position. Now we need to give the fish's data variables here. So save fish.health is equal to data.health. And fish.name is equal to data.name. Alright, that's it. Now we just need to call these save and load functions. So I'm going to save on application quit, on application quit. Just going to say save fish. Now, whenever you're loading a scene, you're gonna need to call all your save functions. And how we want to load is on awake, before the first frame. Awake, we just want to load fish. Alright, so save your class, jump into Unity. Now first I'm gonna go to my save system and assign my prefab. Just like that. And now if you're gonna have any separate scenes, so I'm gonna make a tank 2, you're gonna want to go into your build index and file build index and make sure that all of your scenes are in the build index, just like that. So now we can actually play. Now it's gonna throw an error as soon as we play. Remember, we created a load function, and on the first play there's nothing to load, and I'm gonna spawn the first fish. And I'm gonna give this fish a name. His name is gonna be Bob. I'm gonna give him more health, and I'm gonna turn it off and play. And look at Bob, he's still there. And see if his name is recovered. Yep, and his health was recovered as well. But I don't think his brain has recovered because he's acting strange. At the end of this video, I will show you a bunch of comments from Brackeys Save System video that will give you a few pointers on making a save system, and as well as some things that might help you if you are having errors. And now you can spawn multiple fish, unload, reload, and they're still there. And you can even go to a separate scene and have a separate save. So one fish here, come back in here, the fish is still there, come back to tank 1, and boom, separate fish. And now there's one more problem. If you try to delete a fish or just destroy or ever sell the fish, there's no error until you try to save. It'll throw you an error because you're you're trying to save a fish that doesn't even exist. How do we make sure the fish can just take care of itself whenever we sell it? Fish, you do your thing. So what you can do is create an OnDestroy function on your gameObject. And whenever it's destroyed or deleted or sold, say SaveSystem.fishes.remove this, just like that. Now I go back into Unity, play, delete all of these fish, turn it off, and reload. No errors. Alright, so that's it for this video, guys. I hope you enjoyed. I hope this video helped you out. If it helped you out in any way, consider subscribing and liking the video. And with that being said, I'll see you next time. At the end of his video, he mentions something called Easy Save, an asset that you can download to do your saving for you. It's currently about $30, 50% off. This guy can agree. Jukalina suggests that you use path.combine if you are saving on mobile or any other platform. And you can do this to avoid some platform-specific issues. From Alan Darkworld, you can use a try finally block and call close when working with file streams. Otherwise, if your deserialization fails, the file will remain open, which will cause more errors. This guy mentions using player prefs, but player prefs is not secure and it can't hold much data. From the buddy, if you are building an app and you want to save the game when the app is closed, use application pause instead of application quit. H4Z was something suggests using a temporary using tag when working with classes implementing iDisposable. Moral of the story is, read comments, they help you. And also thank you, Brackeys.